Hello, sixth graders. This is going to be, well, the review of the diagnostic workshop for geometry. So we want to begin and we want to go a little bit beyond to what we did in class, of course. Then we are going to go straight to the point. So check this out. What we want to do here is to open this extension. Let me hide this, please. Okay. And over here, it says measure with a protractor, and I am going to show you this beautiful tool which says protractor over here. This protractor, you just have to type it there in the Google browser, and it is going to say Google protractor. You install it as an extension, and this extension is going to be it's going to take 20 seconds to install, right? So you click on protractor and here it appears, right? We can move it all over, we can measure it. We can measure whatever we need. Now, if you open a document like Word, well, it has to be online. Yeah, I have to open it online because it wouldn't go to the very document. So look, this is the document, the Word document. I cannot open it here. It has to be online. Yeah, so that's it. It's pretty simple to open whatever the document, PDF, whatever you want. Well, so what you do is you take the protractor and you make sure that this very center of it, the center of the protractor, goes here in the very intersection of the arms there of our angle. Yeah, arms or legs, some people call it. And well, they're in the intersection. And what you want to do is to take this green side and place it over, well, all along one leg, and the other one goes all along the other arm, the other leg. And you remember it is meant to measure 228 degrees, right? And look, this is exactly what we have. Well, you might say, no, Alejandro, this is 227, 228.1. Well, it is just because I cannot be that incredibly accurate with the mouse, nor with the pen, because, well, with the pen is even harder to fix it. Well, this is what you have to do to measure the angle. Let's say that you were measuring another angle. Yeah, so you just have to move these all along the legs of the angle that you have there, and voila. Okay, it's a beautiful tool. I invite you to install it. I invite you to use it. It is great. All right. Besides, I want to show you this. I am going to leave this document aside for your access. It has all the links for the different exercises I'm going to share with you. Let's say, for example, using a protractor. So once again, well, we want to have this a little bit smaller so we can tell. Okay, and look, this website explains all the use of the protractor. It has a kind of video, kind of animated explanation on how to use it. Yep, it has no voice. It is just a drawing, just the animation for you to measure the angle. So it explains. It has another animation here. For you to measure that angle, for you to construct an angle, as a matter of fact. Here you're measuring one. Over here you can drag the protractor and measure what you need to measure, and it is beautiful. It is a very interesting idea. Here you have a bunch of questions for you to try on. Well, let's go with the second exercise, and it says here are some triangles and draw a ring around the scalene triangles. So we remember scalene means that two sides are different. Oh, well, as a matter of fact, the three sides of them are different, right? So the measurement of the three sides and the three angles are different. That's why we can identify These two are the Escalene ones. Okay, so once again, for that, we want to come here and we are going to, well, this is using a protractor again. This is a circle. Then let me look for the very exercise we want to find. All right, well, we accept it. And describing points, okay, this is for something else. Well, it seems that everything wants to ruin this video. These are the other exercises. Jesus Christ, look. So, area of plane shapes, interior angles of polygons. Jesus Christ. Now, finally, we got it. Okay, so over here we have then explanations on the addition of angles, how we can realize the measurement of one missing angle in a triangle. Yep. And as a matter of fact, they're in quadrilaterals too, you know. So there are beautiful explanations. There is one for a pentagon, and it says something very important, you know, the addition of the three angles inside a triangle is always, must always be 180 degrees. Yeah. And look at this. Each angle, yeah, then 60 degrees. Even if it is, well, distributed in another form, it will always be 180 degrees. The sum of interior angles in a quadrilateral, whether it is a square, whether it is a rhombus, whether it is a parallelogram, it must be 360 degrees. And so on with pentagon, hexagon, heptagon. And check this. Every time we are adding 180 degrees. Now, every time you add a side, one more side means 180 degrees more, right? So you're going to add 180 degrees every time you have an extra side. Yep, easy for us to realize. Okay, then here is the extra information about triangles. Yep. Well, you can also find how to classify triangles if you explore over here. Yeah, you can see that all these talks about triangles. So we close this promotion and look at this. Triangles, and then equilateral triangle, isosceles triangle, scalene triangle. So all these links I am leaving you is for you to improve, for you to find extra information, for you to get, well, whatever the knowledge that you want to realize about, research about. Okay, we move on. Over here we have this exercise 3, and it says, what about a circle? What are the parts of a circle? Which is the circumference? What is diameter? And what is radius? Yep. And keeping that in mind, well, we are going to say which is greater than or less than the other. I mean, the measurement of each. So let's go and find it out. So now these are, where is, I guess I should close what I am not using. Okay, this one is about the circle. And it says the circumference, this is the radius, and check this distance around, well, the circle itself, is the circumference. And now we have the radius, and so on. They show you how to draw the circle. And look, the radius is going to change, and so the circumference, as you are, well, making it greater, making it smaller. So radius has a direct connection with the circumference distance. And that is what they explain here. Look, they talk about pi. They explain what's going on there with this. So it is beautiful. It is nice for you to once again, keep it in mind for you to improve. Let's answer this. The length of the circumference is greater than the length of the diameter. Yeah, let's come back here and let's not talk about the area, but this. So over here, the length, this distance there in the circumference is, of course, greater than the radius. Of course, greater than the diameter. The diameter is the double of the radius, but however, the circumference is longer than that, greater than that, the measurement. Now, the length of the diameter is greater than the length of the radius. And that's it. Yep. So, you are doing good. Let's keep on going. And here we have a coordinate grid. And the instruction set, remember, ABCD is a square. If you find this instruction like that, ABC, so you say A is a polygon which is constructing a triangle because it only has 3 vertices, right? This one has 4 vertices, A, B, C, D. And besides, they say it is a square. So if we want it to be a square, there is no other possibility but to place it here. Yep. It's not a different quadrilateral for it to be somewhere else but a square. Yep. So, you know, this intersection is -4, 3. It means that over here we are going to write -4, 3, which we did there in class, you remember. We come back here, and over here we have exercises about that. And this is in My Math. You have access to it, you have the codes, and besides, I am giving you the link for you to go directly to the point. So, describing points, yeah, and they well, explain very well about the, look, you can type here whatever you need, and this is going to be very explainful, very clear for you to remember, for you to refresh your ideas about all this information. Yeah, I want you to go beyond. I want you to review very properly, and hopefully we don't have enough time. Nobody has enough time. Yeah. Now let's talk about the cube and the cuboid. So we remember this is a cube because all faces have the same amount of units. Yeah. This is the height, this is the width, and this is the depth or the length. Now it depends on your perspective. Yeah. The fact is that this has 3 dimensions. 3 dimensions, yeah, and that's why it is a 3D object, a solid. Yeah, solid because you can grab it, you can take it, you can measure it. Yeah. And over here we have a cuboid. And it is a cuboid, not exactly a cube, yeah, because it has different measurements in the 3 dimensions it has. Yeah, faces over here are 3 by 3, 3 in the height, 3 in the width, 3 in the depth. Over here we have 4 by 4 by 2. So it is a kind of rectangular prism. If it weren't built by unit cubes, but if we're only one structure, it will be a rectangular prism. Yeah, not a cube. So that's it. And for us to review on it, yeah, I invite you to take a look at this. This link is going to ask you about the volume of each one of the objects. How are you going to calculate the volume of each? Yeah. What you want to do is you want to count. Now, is this a cube or a cuboid? Let's realize about. So we have 1, 2, 3, 4, 5. There on the depth, I want to call it depth. Yeah. And it is 5. Now in the height, it says 1, 2, 3, and 4. 4 in the height. And let's say in the width, 1, 2, 3, 4, 5. So 5 by 4 is 20, right? So you say this only face has 20 units. And now I want to multiply it by the depth of it. No, Alejandro, it's not depth, it's the length. Oh, well, some other people will say it's the width. It depends on your perspective. So 20 times how much? 1, 2, 3, 4, 5 is 100, right? And that is what we are going to type over here. We submit it, and it says we rock. Yeah. Once again, what is the volume of this object? So 2 by 2, 4, 5 makes it 10. 10 on this face times 1, 2, 3, 4 makes it 40. And that's exactly what we want to type. So 40 cubic units. If we were not talking about cubic units, then they will be giving us the measurement. 4 centimeters, 4 inches, 4 yards, 4 kilometers. What is it? Well, in this case, we don't have the measurement, but they are giving us cubic units. So we have to say cubic units. I mean, no unit, no point. Awesome. Now let's do this the last. It is 4 times 4. 1, 2, 3, 4. It is 16. 16 cubic units. Yep. Now, there is something beautiful about this. Oh, look at this. What is the volume of it? Yeah. So let's write something wrong. Yeah. If it is wrong, the beautiful thing about this website is that it explains in a very clear and complete explanation, right? So it doesn't only give you, hey, no, it's wrong, or okay, it's good, and just keep on going. No, it explains very well in case you don't understand it, okay? In some cases, it even helps you there for the answer, right? So let's say this is asking you, and over here it says, hey, work it out. Yeah, I want to remember this, I want to review this, I want to get a lesson about. So you have material, you have enough material, okay, kids? Now we move on, and this is the net of an open cube, right? So I guess I skipped this exercise because, yes, I skipped it because you know that it is basically the exercise. Oh my God, yeah, the exercise we want to solve in our mind. Okay. However, because it is a cube, no matter what the net, the construction of the net is, it must have 6 faces. And if we are missing one, it can be positioned, it can be located in 4 different places, right? Because there are 4 walls in whatever the way we take a look at the cube. Well, we move on, and this one, which talks about area. The area of a rectangle, the area of a triangle. So over here, yeah, I talked, well, I found some exercises, yeah, there for the triangles, yeah, to find the area of the triangle. Yeah, no matter the triangle is not exactly a right triangle, yeah, with a 90-degree angle somewhere, but some other triangle, yeah. And the idea is that you explore, that you find out how it works. Yeah, there are plenty of questions, plenty of material. Okay, well, so now you say, hey, but I don't want to know just about the area of a triangle. Well, so if you explore, you're going to find out there is lots of material. Look, interactive triangles, geometry index. You just type here. You can watch a video about. You type here whatever you want to look for, and you might find it very fast. Now, it says the area. Let's work it out once again. Just in case you don't remember, we want to say this is 6 by 4. So you say 6 times 4 equals 24, right? Now you say 24 is the area. Well, if we divide it by 2, if we divide it by 2, then it is going to be 12. 12 what? Well, 12 is square centimeters. Now it disappears because it is out of the paper. So let's say 12 is square centimeters. And it has to be square centimeters because we are talking about area. But it is over here, this area, the area of one of the triangles. We have 3 triangles over here, 1, 2, and 3. And it says shape B is made of 3 identical right-angle triangles. And the area A and B have the same amount. Is exactly the same amount. So what we are doing here is we want to say, hey, this is going to be then 12 times 3, which is 36 square centimeters. The area of it is going to be 36. It means the area over here is going to be 72. 72 square centimeters. So I can take the 36, I can take the 72, and once I take the 72, I say, hey, I don't even need to divide, but I just have to say what number, 72 divided by 9 is what number? So it is 8. And the answer is 8 centimeters, right? Just to review. Now, here is a triangle. Well, we've been talking about triangles. The 3 angles always add to 180 degrees. Look at this example. It is the addition of the inner angles is 180. So over here we say 57 plus 39. 57. Oops, look at that 7. 57 plus 39. We do the addition. This is 6 and this is 9. 96. How much are we missing? Well, we say 180, which is what every triangle must have inside, must measure in the inner angles, minus 96, what we already have, and that is the missing angle. How much is that? Well, exactly 84 degrees. No unit, no point. Keep it in mind. Keep it in mind. So now draw a circle with a radius of 4 centimeters. Well, we've done it in class. And I was looking for a video, and all people grab the compass in a wrong way. I taught you the right way, grabbing it by the very top of it. I guess I might make a video about using a compass properly, because what I researched was kind of worrying. Kids, enjoy. Once again, next to the video, I am going to leave the links for your research. Okay, bye.